Okay, so now I want to introduce the concept of autoencoder, which is consists of an encoder, a decoder, and in the middle here we have our latent space. And as an example, now let's assume that here we have a neural network, deep neural network. So the input is basically a vector of the images of length 7084 times 1. So each image is 28 times 28, which gives 1784 binary values. So which we put them all in a single vector. That's basically the size of the first layer. And what happens is that after it goes through the first layer has 788 neurons, and then we want to encode this huge vector that has a lot of information, and maybe all these 784 values. There is a lot of redundancy there. That in order to identify that this is a number 3, we may be able to do it with less than 1784 numbers. So, we're gonna basically define a neural network in which the SATA layer is made, for example, of 256 value, and then, the last one here, we end up, for example, with 64. So they are 2056 neurons. So this is basically the input layer. Then here we have an hidden layer. And this is the output layer. And, for example, here we can even reduce them more drastically to 32, for example. And what happened, the input, which is basically this huge vector, after it goes through the neural network, we will end up with this latent vector Z, which is dimension 32 times 1. This is the latent vector, which, imagine that we can represent it. Imagine that we just plot the first 3 components of this vector. Remember that this vector basically has component z1, z2, and so on until z32. So this image here becomes basically a point in the latent space. Okay, so here we have a reduced representation. This is also called vector embedding. Embedding. In which we represent an image with a vector of lower dimension. And then what happened is that, of course, and then given this vector, we pass it into the decoder, which is exactly the reverse of the encoder, and which will return us a vector which has dimension as the original number of pixels in our image, of our image. And of course, all this, both the decoder and both the encoder and the decoder, they include weight matrices and bias vectors. This is one for this, then we have another one for this layer. And then, there is also the weight matrix for the third layer. And similar here, so this is basically, this is the encoder. And on this other side, we will have the same matrices for the decoder. W1. And so what happened altogether, this is called autoencoder. Why? Because we start with an image, and then we do this vector embedding into a smaller latent space representation, and then we decode it back to the original size. And the training of the autoencoder, it is done in such a way, find the weight matrices and bias vectors such that the output of the network here match the input. So for any given data set, we want to make sure that once we want to find the weights and biases of this autoencoder in such a way when we pass our data set, we will get out also the same data set. Okay? Once you do this training, what is the power of the autoencoder? Is that, for example, if we have all images that are very similar to tree, in the latent space, they will all cluster near all together. So here now, for example, we have all the points that correspond to all the images that correspond to tree. And then, for example, here we will have all other images whose latent representation correspond to a two, and so on. So what happens is that in the latent space we have an easy way to deal with to see better what is the content of our all images. And there is something more, is that the output of the first layer, the weight matrix here, the first matrix, the weight matrix of the first layer, has dimensions, because we need to pass 784 times 256. Okay? And what happened, we can represent this matrix like this, in which the columns of this matrix, they have the same size of 784, and then we have 256 features. So what happened that the columns of our weight matrix, the column, they can be reshaped as 28 times 28 images and correspond to features that the autoencoder learn about our data. So there is something also to consider. So why is the autoencoder useful? Because once we have a latent representation of our images, we can basically do interpolation. We can do image interpolation between images. or we can do style transfer. And I'm going to show you how you do that in simple Word.